we're going to be having a fireside chat, but meanwhile, I'd once again like to thank all our panelists as they exit the main stage. Now for our final fireside chat, which is going to be on how will AI and ML impact SD-WAN and SASE. We're looking at talking about how machine learning changes SD-WAN, main characteristics of the new era, how machine learning can be used to optimize the application experience using pragmatic approaches focused on clear use cases. For this, we're joined by our eminent guests. First up, Samuel Ng, who's the Director of Cybersecurity and Analytics, Hong Kong Applied Science and Technology Research Institute, ASTRI. So Samuel is responsible for the strategic planning and leading the R&D directions of the cybersecurity and data analytics. He's somebody who leads a team to conduct research and development projects in security assessment, network security, threat analysis, and cyber defense technologies. We're also joined by Zeus Kerravala, who is the founder and principal analyst, ZK Research USA. Well, Zeus, being the founder and principal analyst with ZK Research, provides a mix of tactical advice to help his clients in the current business climate and long-term strategic advice. With this, I now present Samuel and Zeus on your screen. Over to you.
All right, thanks, Vabna. I appreciate the introduction. Thanks, everybody, for joining us in this session. I'm Zeus Kerravala from ZK Research, and I'm joined by Samuel Ng from the Hong Kong Applied Science and Technology Research Institute. We're going to be talking about artificial intelligence and machine learning in the world of SD-WAN and SASE. And Samuel, it's great to talk to you about this. Why don't you introduce yourself?
Yep. Hello, everyone. Okay, this is Samuel from ASTRI, Hong Kong Applied Science. So I'm a director of cybersecurity and analytics. So what I do is I lead the research directions of ASTRI in cybersecurity. So we try to use emerging technologies, AI, machine learning, neural networks and stuff, deep learning into reduce labor-intensive work and to try to collaborate with industry and commercial companies and then to bring more value to them based on research. Yep. Thank you.
All right. Thanks. Yeah, and my background's more, while I do some security research, I'm more on the networking side. So this will be a pretty good topic. We're going to be talking about AI and ML in both on the networking side and the security side. And I know Sam, you're stronger in security. Now, on the SD-WAN front, obviously there's been a big shift from traditional networks to software-defined WANs. You know, the rise of AI ops integrated with network operations, I think, has been driven largely just by the complexity of the network. If you think about the way networks were designed before, they were relatively simple in nature. They were hub and spoke. You had all your security at one location. And so from an operational standpoint, managing it wasn't, I'm not going to say it was easy, but it wasn't that difficult. There's a lot more complexity now. There's unpredictability. People using broadband. And I think artificial intelligence is being used to, I'm not going to say quite predict outages, but at least be able to, you can set a baseline, you can then monitor how things are performing, and then when you deviate away from that norm, that can be used actually to understand why that was and change behavior. On the security side, the implications are much bigger. So Samuel, I'm going to turn it over to you, and why don't you talk about what's going on with AI and security?
Sure. All right. So let's compare a little bit about traditional WAN and the new SD-WAN. So from the main point that I see is the volume gets bigger and bigger. So when the volume gets bigger and bigger, from cybersecurity side of view, we will talk about attack surface. So when attack surface goes bigger and bigger, and of course, that leads to cyber risk. When the risk is higher and higher, and then you see where I'm coming from. So now the point is risk is, you cannot have a zero risk environment, right? Right. So that's only, we need to manage risk. So if you have risk, and then you must go on the risk appetite. And then if you have something that your appetite cannot take it, and then you mitigate, cannot mitigate, you transfer the risk. Okay, so that's on the risk part. So when the volume gets bigger, there are two parts that will bring problem to cybersecurity side. Number one, it's human errors, because when the volume gets bigger and bigger, human errors will come. So when human errors will come on the cybersecurity side, you will have threat alert fatigue, because from my own experience in banking and other companies, the defenders have this problem of false positive. So when false positive comes, because I can say 8 out of 10 alerts are all false positive at the moment. So that is why, to answer your question, AI and machine learning needs to come in to help, because human capacity has a limited capacity. So of course we need AI and machine learning in this part. Yep.
Now, when you said the attack surface is bigger, can you give me a sense of the magnitude of how much bigger it is?
All right. Well, you see, when you go into SD-WAN, means when you are introducing more different new types of attack and new types of convenience for the attackers. So like traditional WAN, you are just handling those controls, configurations back in your own network. But when you go SD-WAN, means you have your control panel on the cloud. You have your management console on the cloud. So when your management console is compromised, then you will have a single point of failure. When the single point of failure, then resiliency will be a problem, right? So yep. So how about from your part? I mean, from traditional to the new software defined, what do you think there's a difference between them?
Well, on the operational side, it just well, first of all, your point on human error is good. My research shows that with traditional networks, the #1 cause of downtime at 32% is human errors, right? And that's because of just the way we run networks. We're always in firefighting mode, it seems. And with networks today, networks don't really go down anymore. We build them with a lot of redundancy in mind, and the network equipment's pretty good. The bigger problem is when something's not quite working right.
Okay.
Right? And yeah, it's those brownout situations where you've got some performance issues, but you really can't figure out why. And in that case, the network engineers are always, and I'm a former network engineer, and I used to tweak the network all the time, trying to make things work a little bit better. But then what happens is you introduce a lot of errors, and I think and you can often lose control of that. And so your point on the volumes is correct too. With most modernized network equipment, if you think about the information that used to come off network equipment, there was a lot of pulled information. So you get a ping every 30 seconds. Now it's all real-time stream telemetry, and so there's a massive amount of data that you're working with. And I don't care who the network engineer is. You can have the most seasoned network engineer, but the volume of data is so great that it's really difficult to interpret. And I know on the security side with SIMs and things, it's the same problem. It's just that there's so much data today that you can't really make sense of it. And so that's why, machine learning has become so important, because machines can constantly, they can watch everything and make sure that things are being caught, right?
Yep. I agree on that. But machine learning, there's quite a long way to go for them. Sometimes, where human also needs a lot of time to learn, so machine needs to learn as well. So the biggest thing to bring effectiveness to machine learning and AI is the human experience itself, because machine learning and AI is actually very simple stuff. We ask them the right questions, and they answered. So when they are wrong, we correct them, and then they will start to they learn. But that requires time. And actually, from my experience, when in the operation side in the banking, bad things can happen. Network down, server down, certificate expiry and crash and stuff. I think some mindset has to change here. Instead of blaming the network engineers for not doing due diligence, and when the server is down, you start to blame the engineers and stuff. I think it's the best thing is to change the mindset, where every problem or every incident, there is an opportunity. There is something to learn. and from there we can pick up stuff, and we can do research on it, and then we can fix the problem. To me and my team, to mistake is human, but to repeat it's stupidity. So it's the best thing is to improve, right?
How accurate are AI systems for security today? And I do caution buyers, because I think there's this notion that AI systems have to be perfect, right? And they're not perfect. And to me, the barrier to entry is just better than humans, but humans make a lot of mistakes that we've just been talking about. So if people implement AI systems, what level of accuracy can they expect? And I know these systems get better over time. How quickly is the learning period here?
I have a point to share here. AI is not perfect, definitely. Sometimes I blame the movies, like Resident Evil, the Red Queen and stuff. You can see the AI talking to you, But I would look AI and machine learning in a part of repeating mistakes. So of course there are new problems and humans do mistakes. So what we do in ASTRI is we try to use AI and reduce the repeated mistakes, because we use our experience to teach the model. You see, but then when there are new problems comes, AI might make mistake. You see, so we have to. That's how we do in ASTRI, is that you can say that we are holding the hand of the model and then try to bring it from time to time. It's try to improve. It's like training a baby, but when it grows up and then it becomes an adult, it can solve the problem itself. But when new problem comes, well, cybersecurity is for a CISO or senior management, cyber risk is one of the most unpredictable risks, because new exploits come and you don't even know what other exploits are in the wild. It's like WannaCry 2017. That exploits that incident happened on 2017, but that exploit exists back in 2012. So there are 5 years of zero-day time. So no one knows what has happened within that 5 years. So that's why cyber risk is very unpredictable for CISO, for senior management. They have this problem.
And from the people that you've talked to that are using AI for security, are they using it to find breaches, or are they also using it to remediate against and just taking the recommendations?
Yeah, good point. Actually, both. So let me go on the second one first. To remediate. Well, to remediate means that the human has to remediate before, or there are some key, we call it IOC, the indicator of compromise. So of course you can teach that if you are opening 3389 port out towards to external, or maybe some engineers accidentally open port 3389 remote access, remote desktop protocol out, and then the AI will shut it down. But some new stuff, like maybe you opening up, well, you have so many ports in the network, right? So let's say you open up port 55555, the AI might not know what to do yet. Not even humans, right? So when humans, you see an uncommon port open, you might have to go and scan, doing a service scan and see what service is running behind that. Is the service vulnerable and stuff? This is still very human. So it's one by one. It's really by our experience. Yeah. So
yeah, from the security pros that I've talked to, most of them are willing to use AI to find the indication of compromise or the breach, but they're not fully willing to trust it to solve it yet. So most AI systems now give recommendations, and I think that's okay. If those become data sets back into the model, right, that'll help improve the model. So I think from that standpoint, it's a good thing. Now, if what are the, so in the security world, there is a vast array of problems, right? There's network problems, there's EDR. I mean, people are talking about XDR now. There's, you know, web breaches. What's the low-hanging fruit? What are the if somebody wants to get started with AI and security, where should they apply it with, you know, a minimal amount of risk? They can build some confidence that these things work.
Well,
because they're not going to deploy it everywhere all at once, right?
Yes, exactly. So the low-hanging fruit will be, of course, the simple part first. I mean, I used to come from the army. I worked in the army for 14 years. So let me give a brief metaphor about this. So you can consider AI as one of your soldiers. So soldiers, they have their rifles, they go to the war, but then they still need their commanders to tell them what to do at some point. Well, they can fight the enemies, and then, you know, but then they still need the commanders to brief them the mission, what are we trying to achieve, you know. So, well, the low-hanging fruit will be the simple repeated mistakes, like maybe you know, when let's say you have your DevSecOps, your programmers are writing codes, your developers are actually developing the tools. When they have something, input validation, they did not do an input validation, and then that should go. So it's back to the basic part, you know, that will actually solve the problem from the root. So from the root, and then you will, you know, you'll bring less problem in the future. Yeah. It's always the best thing. I would put all my effort to build the foundation strong, because whatever you build now, it's not for right now. It might be 10 years later, 20 years later. Yeah.
And for AI systems, do they have to primarily be cloud-based? Just because most businesses don't have the compute power on-prem, nor do they have the data scientists on-prem either, right? So how do people implement these things?
Well, I think it really depends on the organization itself, because some organization will focus on CapEx, some will focus on OpEx. So like ourselves, for ASTRI, we are doing research and we create a new product. We solve people's problem. So we will try to, and then once the project is done, we will transfer the whole system to our clients. So from our part, we will focus on OpEx, because in the end, we will transfer the technology to our clients. Like us, we try not to invest in CapEx, because when we buy servers, we buy all the hardwares, and then we transfer, and then we'll have a problem. So some companies, like startup, like I used to be a head of cybersecurity in a startup bank. So that time we focus a lot on OpEx as well, because startup needs to be quick, needs to be fast. And of course, we utilize a lot of cloud technologies. At that time, I think 90% of the bank infrastructure are all in the cloud, even the core banking system. So we cannot have, we need to launch to the market fast. We cannot build our data centers and stuff, you know, that's not enough time. So, yep.
I would just think the rate of change is so fast too, that unless you're a really big organization with your own data scientists, it'd be hard to keep up. I know with SD-WAN, one of the big use cases is app optimization. I think this is an area, especially with cloud-based app, that companies really struggle with. You know, there's more and more video being used, there's more traffic being used, and a lot of it's very unpredictable, especially with people using shadow IT. And I do want to talk about that with you in a second, but from an app optimization perspective, the AI can actually, machine learning based systems can actually almost predict when applications will start working poorly, right? So if you've got a good baseline, and that's really important, is to allow the machine learning based strong baseline, and it's able to measure that deviation from norm and project out in the future, and then it can actually predict when applications will start performing poorly. And I think that's one of the big benefits of bringing AI ops into SD-WAN. I did mention the S for shadow IT. You know, that's become a very big topic. In fact, I think that's the single biggest problem that companies have today with trying to run networks. They just don't know what applications are running on their networks. And so give me a sense of how companies can use machine learning to fight shadow IT.
Well, let me share two parts on this. One part is on the governance side. Governance side, I will split into three parts, which is people, process, and technology, right? And then the second part will be zero trust framework. Well, shadow IT, I really like this topic because I used to be a red team leader, and then I go into people's organization and try to hack their network and try to find vulnerabilities. So we found a lot of shadow IT stuff as well at that time. So people, process, technology. Well, let's go to the low-hanging fruit. People. I mean, it's the usual stuff: background checks, HR and stuff. Criminal records and. But process, it's well, technology is a problem because when you have good technologies but you don't utilize them, that will lead to a problem. So people, of course, you have good people, and process, of course. Process means that you have a governance process, you have change management control, you are having you want to do a single change in a production network, you need to go through a lot of request approval process. But I do understand change management will take up a lot of time, will take up a lot of approval process. But I think the most headache part is to balance between the operational speed and security. So that's one of them. And technologies, of course, there's a lot of tools out there like CyberArk and stuff. Can do zero trust framework and stuff. So
yeah.
Shadow IT, it's well, now I've been thinking a lot of this. Okay, now the problem here is you have CyberArk. The engineer, when they have to do changes, they have to do something in the servers, they can jump in and the session is recorded. But the problem is who checks the recording, right? So what I did previously was our SOC has something called malicious command detection. Well, of course, it works quite so well, but it does bring a lot of false positive as well. Like, let's say we have a network engineer running wget command in the network, and then we will actually sound an alert, but only on critical servers. So when so we have a set of malicious command that is detected in our SOCs. So we really utilize that SIEM tool in our SOCs. So we remember having people running malicious command, and then we were able to detect, and then we try to we solve it really quick at that time. And of course, SOC and SIEM, it's you need to feed them more data. So what we are currently doing now, one meaningful project in ASTRI is we have something called HoneyNet. So HoneyNet, it's okay. Honeypot is not something new.
Yeah.
And we try to collect, which we try to put different honeypots in different organizations, including the bank, the police force, and stuff. And we centralize all the data, and then we share the data to the SOCs and different partners. So the detection will be quick and fast at the time. So because shadow IT operations, when they do have malicious intent, I mean, hacking is not like a press of a button and then everything works. They'll be trying at the back end. So when they are trying their commands, and then we will be able to detect already. So that's what we did back in those days. Yep.
All right. Well, I'm looking at the clock here, and we're almost out of time. So
yeah, okay.
Just real quick, I always give people advice that stop studying, and the best way to get started is to just get started, right? Put the systems in.
Let's do it.
Yeah, and I don't know if you have any other advice for the audience on how to get started. All right.
Okay.
All right. Well, if not, then we are almost out of time. So Samuel, I want to thank you for your time. I think that was a good discussion, and I'm going to turn it back over to our MC now. So thanks for joining us, everybody.
Thank you very much.
So thank you so much, Zeus and Samuel, for that excellent session and the fireside chat.